plate capacitor consists of two similar large plain conducting sheet or conducting plates separated by a small distance. Let us say this is a parallel plate and this is another parallel plate. Both the parallel plate, this is a conducting plate and this is another conducting plate. These two are parallel and the dimension of the plates are infinite. Is it possible? Infinite? If infinite, then how can we use? It can be considered as an infinite plate if the distance between the two plates is very small. Consider a wall of a room. Is it finite or infinite? Finite. Why finite? Because we see the end points of the wall, right? Now go close to the wall, very close to the wall. Now can you see the end of the walls? Then you can assume the wall as infinite plane. That's why, like similar way, if the distance between these two plates is very small, then these two plates can be considered as infinite. The area of each plate is A and D is the distance between the plate. Then if D square is much less than A, then these plates can be considered as the infinite plate. Now what we have considered? We have considered two similar parallel infinite conducting plates separated by a distance D. The medium in between the plate is vacuum. If we put a plus Q charge on this plate, plate 1C, and this plate 2, then this plus Q charge will be distributed uniformly over this plate, and the surface charge density of plate 1 will be equal to Q by A, and this is positive. Since plate 2 is close to the plate 1, then nearer side of the plate 2, that is which is closer to plate 1, there will be a charge induction or there will be charge induced, and that charge will be minus Q, and on the rear side there will be plus Q charge induced. This plus Q charge. Now if we connect this second plate, that is plate 2, to earth, then this plus charge goes away. That means these charges will be cancelled or neutralized by the charge of earth. Now this charge also, this induced minus Q charge will also be distributed over the second plate, and the surface charge density of plate 2 will also be sigma equals to Q by A, but this will be negative. That means there is two infinite plates, plate 1 and plate 2, and plate 1 is charged with plus sigma surface charge density, and plate 2 is charged with minus sigma charge density. Now already we have discussed the field due to this system. If this is an infinite plate, infinite conducting plate with charge density plus sigma, then field at this region will be sigma by 2 is also sigma by 2 epsilon 0, right? And if there is a minus sigma, there is a plate with charge with minus sigma charge, then also there is a field, and this field will be equal to sigma by 2 epsilon 0, and this is pointing towards the plate, and for the plus sigma charge distribution, the field will be away from the plate. Is it clear? Now if these two plates are close to each other, then what happens? Then in between the plates, field is added, and on the other side of the plate, that means in this region, the field due to this plate will be away, but due to this plate will be close, near towards the plate. Then in this region field will be 0, in this region also field will be 0, but field in between the two plates will be equal to E equals to sigma by 2 epsilon 0 plus sigma by 2 epsilon 0, that is sigma by epsilon 0, and the direction of the field will be from plate 1 to plate 2. We have discussed earlier. Now we can say that the field between the two plates is sigma by epsilon 0, and its direction is from plate 1 to plate 2. Now the region between the plate 1 and plate 2, there is an uniform electric field of intensity sigma by epsilon 0, and its direction is from positive plate to negative plate. But there will be a non-uniformity if the plate is finite, and in which region? In the end region. In the end region, there will be a bending of the electric field lines. There will be bending of electric field line, and that is called the fringing of the field. Fringing of the field. Now, if the field between these two plates is E equals to sigma by epsilon 0, and which can be written as Q by A into epsilon 0, since sigma is equal to Q by A, while A is the area of each conducting plate. We are going to calculate the capacitance, and capacitance is the charge divided by potential. We have given Q charge. Now we have to find out the potential difference or increasing potential difference between these two plates. Right? Initially, potential difference was 0. When there is no charge, potential difference between the plate was 0. Now, if we put Q charge, there will be potential difference, and that potential difference we are going to calculate. Now, what is the potential difference between these two plates? Now, potential of plate 2 is 0 because it is connected to R. Therefore, potential of plate 1 is equal to what? Potential of plate 1, that is the potential difference between the plate 1 and plate 2, is equal to the amount of work required to bring a unit positive charge from plate 2 to plate 1. Work done to bring unit positive charge from plate 2 to plate 1, and that will be equal to force into displacement. And what is the force on unit positive charge? Force on unit positive charge is E, that is electric field intensity, that is E. And what is the is from plate to plate 1, that is the distance is d. Therefore, we can say the potential difference between the two plates, plate 1 and plate 2, which is the potential of plate 1, because potential of plate 2 is 0. So we can say V equals to E, that is Q by A epsilon naught into D. Now the capacitance of this capacitor, that is capacitance of a parallel plate capacitor, is equal to C is equal to Q by V. Now Q, what is V? V is Q into D divided by A into epsilon naught. That means Q into A epsilon naught divided by Q into D, which is equals to epsilon naught A divided by D. C equals to epsilon naught A divided by D is the capacitance of a parallel plate capacitor. And from here we can say, or we see here, that the capacitance is proportional to the area of the conducting plate. If area of the conducting plate large, capacitance will be large. If area is small, then capacitance will be small. And also it is inversely proportional to the separation between the plate. If separation between the plate is large, then capacitance will be small. If separation between the two plates is small, capacitance will be large. This is the parallel plate capacitor with vacuum in between the two plates.